Hey everyone, welcome to this edition of Microchip Technologies live stream. We're coming to you live here from Microchip Technologies corporate headquarters in Chandler, Arizona. This is going to be your opportunity to ask us questions or make a comment on today's topic, which is rapid prototyping with clipboards using Atmel START. My name is Mark McComb. Joining me in the studio today is my good friend from Trondheim, Norway, is Jacob Lund-Lassen. Welcome, Jacob.
Hello, thank you.
Inside of our booth, we have Matt Dickens and Wayne Freeman. And Matt, why don't you tell everyone how they can ask a question and talk about the prizes that we have today?
For sure. Thank you, Mark. Hey, I want to give a quick shout out to Digital World for being the first person to say hi. Welcome.
Hey there.
Glad that you guys are here. This is my buddy Wayne, and we'll be kind of answering your questions and making sure everything goes smoothly. So yeah, if you want to ask questions, there's two super simple ways to do it. Number one, you can go to live stream at microchip.com, send us an email there, and we'll be monitoring questions from that, as well as doing comments and questions on the live chat for the YouTube. So I'll be monitoring that, try to get all those good questions in as the live stream continues.
And by the way, I want to say hello to everybody on YouTube land. This is actually our first YouTube live stream.
Oh, cool.
We're enjoying the platform here. It's awesome. Back to you guys.
Great. Again, ask lots of questions. That's why we're here. Make some comments, suggestions for future live streams, and so on. So, Jacob, today we're talking about a couple of things. The primary thing is rapid development. Can you kind of explain that a little bit, what that means?
Absolutely. So what we're talking about when we're talking about rapid development or rapid prototyping is actually both hardware and software.
Okay.
So many are probably used to the term rapid prototyping, where they're doing something, they have a small board, they have maybe a breadboard, they're putting components together, do that sort of rapid development on hardware level. But we're also going to talk about rapid development or rapid prototyping on a software level, even on application level today.
Very cool. And one of the things we're going to do today is we're going to take a look at a demo. The demo that we're going to use is actually using a clipboard. Jacob, can you just tell me where the clipboards actually fit into all of this?
Absolutely. So the clipboards, if we should just take one of those here, are small modules that you can put onto your application or your prototype. And these modules, they would then give you dedicated functionality. So for this one, for instance, you have GPS functionality that you can interface directly. So instead of building your hardware piece by piece, you do it module by module.
Very nice.
And that is easier because that would then allow you to do the software stuff that you actually want to move to do your application.
And a lot of these clipboards actually make use of very common connections that you'd find on almost any microcontroller, right?
Yeah, that's a good point. So what we have here is a standardized interface. So this is defined by MikroElektronika. They have put up some connectors here. They have serial communication, so that would be I2C, SPI, UART that you have on these, and also a little bit of analog and reset. But this is a standardized serial interfaces that you use in most application for interperipheral communication or communication on board. Well, of course, if you go off board, it would be other things, USB, right, Ethernet, and so on.
And Jacob and I actually sat down with the clipboard that we're going to be using today. It's the Noise Click, and I think that's a kind of a great example of integrating the hardware onto this single module rather than going with the traditional breadboard approach, because we took a look at this thing and it's got a Microchip DAC on it. It's got some op amps. It's doing some things that you would normally have to breadboard, but it's integrating it onto this little board. So you just connect it into our AVR or our Atmel Mega Pro board, and we're off to the races.
Yeah, and a point here is that maybe you have a software background. Mm-hmm. Maybe you do not really know how to connect these op amps and the analog stuff, make that work.
Yeah.
So here you have a finished solution for you. You can grab it, you can use it, and you can actually do your prototyping from the software perspective instead of spending time doing analog research.
And again, we easily got our hands onto the schematics for this product, so if you decide that you're going to go with this to production, I mean, it's a pretty easy transition. So as far as the clipboards go, we have this nice integrated solution in hardware, but what does Click Start mean?
So Click Start is an expression that we've sort of come up with to give you an indication of you combining the click boards, so the boards that we're talking about here, the small boards, with the environment that we have built to generate code for you very easily. So Atmel START, which is a code generating tool that can make drivers, configure peripherals, and so on. So the combination of clipboards and start, click start. There you have
Excellent.
it.
And I mean, this is a great way if you want to easily incorporate sensing, control, communication functionality, again, using this click ecosystem. But again, the whole goal here is just to make things as easy for you, the developer, as possible. So again, rapid development, correct?
Yeah, and maybe we can just introduce a few of the modules we have
Sure.
here. There's a lot of modules.
Yes, please.
So, but some of those that we have here, for instance, an accelerometer. If you want to have some motion sensing, want to do a drop test or drop detection, you could put accelerometers on your application. We have Bluetooth, the RN4871 click. So if you want to have Bluetooth, you can connect with your phone, tablet, PC for that matter, transfer data.
And again, that's a Microchip module on there.
Yeah,
so,
it is.
and it's made to work with Microchip parts. I mean, a great way to add Bluetooth without having to build this all yourself.
Yeah. Then we have the GPS. So for all kinds of tracking, if you want to build tracking system for your car, for your bicycle, do-it-yourself way, you can take this module. You can then combine it with, well, we have some more Bluetooth here, we have some more sensors here, but basically what you say is that if you want to integrate with sensors, other interfaces, communication, and so on, you have it all here.
Excellent. So we have a comment from the booth.
Hey guys, sorry, I just remembered I forgot to mention one thing. As part of the encouragement to participate and stuff like that, we will be handing out some prizes throughout the live stream. So
Oh, yes.
feel very free to ask questions because we'd love to answer them here.
And asking questions is the way you qualify to get a prize, correct?
Correct.
There you go. Okay. So Jacob mentioned a little bit about START. We're going to do a demo with that shortly. But we also have some really nice baseboards that have been developed for the AVR products. Jacob, can you run us through a couple of those?
Yeah, I can. So the first one we have here is one of the explain boards. This is an explain mini board where you have a built-in programmer and debugger on the board. And then of course you have the target device. In addition, you have a few touch buttons here. You have to add the software for that, but you have also a lot of, let's call it prototyping area, where you can add components, but you actually have it laid out so that it can match with specific standards. So for instance, the Arduino standard would fit well with this one. So you have that marked out where you can put the headers in, and then you can put, for instance, an Arduino compatible shield on top of that. So now you have the building blocks that you start using to connect all the dots here.
And that's a board that actually fits the Arduino footprint, but accommodates clipboards. So not only can you take advantage of all the Arduino shields, but you can also take advantage of the clipboards as well. That's really cool.
So this is a combination.
Yes.
Absolutely. Then we also have another board here today. So that is what we'll use for the demo that Mark will run. So this is an Explain Pro, a tiny 817 Explain Pro board. So here you have a little bit more features. So first of all, you have some of the connectors mounted. They would fit in with the Explain extension boards. But you also have the program and debugger, and you have a few other features as well. Since this is a pro version, you'd be able to measure the power consumption, for instance. So if you're building a low power application, very convenient. You can actually do that while you do the debugging, while you run your code. You can see that you're in sleep mode, out of sleep mode, turning on LEDs, whatever is actually consuming power in your application.
Now, if you wanted to go beyond and maybe use one of the more advanced debugging tools like an Atmel Ice or a power debugger, I've also noticed there's connection here. We can do that as well, could we not?
Yeah.
Awesome.
We can.
Excellent. Okay. Now, one of the boards that is being used with the, and by the way, the product we're going to be using today is the attiny 817, which is a more recent Tiny product. You give maybe we should talk a little bit about that product, because this is a really cool new device.
That's a good point.
Yeah.
That would just we have to give that an introduction, because there's been a long while where we haven't really come out with a lot of new AVR products, and we have of course gotten a lot of questions about that. And now finally we have started to come out with a lot of really, really nice new AVI products. So the attiny 817 is one of those first new products that are coming out in the AVI series, and there's a few more in that series. So you can go have a look at those data sheets, see what these devices would actually bring you.
And with that, there's also some great core independent peripherals on there. There's and all of this you'll see as you get more into the whole ecosystem, you'll see how this all kind of plays together. The core independent peripherals with START, because it's a hardware-based solution, it mates very nicely with the START ecosystem, so you can set things up, and along with these low-cost tools. I mean, this mini board is very inexpensive. One other thing that we should probably mention before we move on is just the micro bus expansion header that we have connected into the board, the attiny 817 Pro board here.
So here, I'll just turn it around so you can better see it. So here we have an extension board, so that is just an adapter board actually, but that board is then identifying itself to the host controller here, to the embedded debugger on the system. So in that way, when you connect this board to Studio will not only recognize the baseboard, but also the extension board.
Very nice.
It would, unfortunately, it doesn't recognize the micro board that you have on top here, but it does recognize the rest and helps you then set up your project in Studio correctly. I think we have a question.
Hey, yes. So we have a question from one of the users in the audience. Does the attiny 817 RTOS support free RTOS?
So free RTOS is supporting most of the AVI products. The attiny 817, I'm not sure if that is specifically on the list yet, but it's something that should be very easily done, porting the RTOS to that device as well. It's compatible.
Cool. Sounds good. Thank you.
Okay. All right. One thing I wanted to make sure to mention was that any of these tools that we're using today are going to have a part of them a very easy to use contextual help. So as Jacob mentioned, when you plug in these boards into Studio, a start page actually pops up, and you'll see that later where you can have quick links to the data sheet, to the user's guide for the given board. Rapid prototyping just doesn't mean we've put the hardware together for you. Rapid prototyping also means the amount of research you have to do, the amount of searching for things on the web, that gets minimized as well. So we consider that whole rapid development to be an ecosystem. So easy to use software tools, and part of that easy to use strategy is not only the peripherals, but also the tools themselves and finding the help you need.
And as you say, one thing that you have it in Studio actually, but you have it throughout all the products. In START, for instance, where you have the small question marks that would pop up context, relevant, help, and so on.
Exactly.
So, but we'll get back to that. That's something that is really helpful.
Very cool. Okay, so what we're going to do is, I guess we'll go into the demo now, guys. So what I'm going to do is take some time and demonstrate how this noise click is actually going to get used. And just to kind of reiterate the equipment we're using, we have the attiny 817 Explain Pro board. We're using the microbus expansion header connected into this noise click.
I guess we'll put some links in the description afterwards so people can find those things.
And actually, the links are in the description, and we're also putting an image of the boards and basically in front of you on the screen.
Excellent.
At various times.
Wonderful. Okay. So what we'll do then is we'll just jump right to my computer screen, and I'll show you how we're going to get this demo working. So if you notice here, what I've done is I've navigated to start.atmel.com. Atmel START is an online tool. And if you take a look at the home page, you'll see that there's a bunch of resources here. If you want to browse some examples, you can do that by clicking here. There's some videos. If you want to take a look at the Getting Started guide, video tutorials, and so on.
So, and we have more videos than just this one. If you go to our Microchip channel, you'll find a lot of other videos both on START and all the other tools that are very, very helpful.
Yeah, Glenn Nilsson, one of our engineers here, is really got a talent for making things, explaining things in a very intuitive fashion. So I really encourage you to check out those videos. What I'm going to do here is, rather than use an example, I'm just going to create a new project from scratch. So I'm going to click that button right here. And what you'll see that opens up is the Create New Project window. And you'll see on the left, there's a filter. Over on the right are all the parts that are associated with what you enter into that filter. And one of the nice things with this is that you can actually go in and select things like, I want to use an A to D, I want to use a CAN application, I want a DMA to be available. And as you select these different drivers, you'll see that it parses through all of the available products. And that's a really nice feature I like with START, Jacob, is that it allows you to kind of just parse through all these parts that maybe people don't know what they need, you know?
Yeah, that's true. So this works pretty much as a product selector, but you do it one step further, not just asking for a UART or CAN, but you're actually asking for, I would like a CAN driver, a UART driver, and that would then give you that selection.
And not even just hardware, but I mean, if you want to implement a bootloader, or if you want to do crypto, I mean, that's all listed there as well. And in fact, what we'll do here is, inside of the search for software, is we'll look for the noise click, which has been added to START. So I can just type in noise in this search field, and you'll see that it kind of minimizes our middleware search. And I can go in and click on the noise click here, which has been recognized, and I'll add one. And look what happens. Automatically, it kind of parses through the different products and says, hey, all of these products can be used with this clipboard.
And this is just one of many clickboards.
Absolutely.
So we have a lot of those. So if you have a specific clipboard in your drawer or on your desk, go in, give it a go, see if you can find it. If it's not there, probably we'll add it along the way.
They're adding them all the time, yeah. I think we have a question, Matt?
Hey guys, yeah, we're getting some great participation on the YouTube. So all of you out there watching, thank you so much. Quick question on the YouTube, yes. Okay. I was born in the 1920s, actually, so that's what I refer to it as. But Fabian had a question, and he was asking, can these modules work with any MCHP tool? So I'm assuming he's talking about the click modules and things like that. Can you use that all over Microchip, or is this just an AVR-specific thing right now?
Well, if you want to use these clipboards with some of our other 8-bit products anyway, you can use these using the MPLAB code configurator. And in fact, and Matt will be talking about this at the end of the episode, next week I believe Mamoon is going to be doing a live stream specifically on those tools. Is that correct, Matt?
Yeah, we'll cover that a little bit later, but you guys can look forward to that.
Yeah, so yeah, the goal with all of this is to, if it's easy to use with an AVR, it's easy to use with a PIC. Right now there's 2 ecosystems to use, which are great ecosystems, but they're very much running in parallel with the functionality that they can do, correct?
Yes, absolutely. Okay. So same but different.
Yes.
We have one more question for you, actually.
Okay, another question?
Yeah, one more question. Does Atmel START have any attiny examples that people can use to kind of get off the ground?
Yes. And
it's kind of a segue into...
That's
a perfect question, because the board we have here is a attiny-based board. So there you actually have these examples for those. So the 817, the Attiny 817 is one of those products. And you'll find a lot of examples that you can use. So as Mark said initially, you can either start out with making your project from ground up. You start adding the different drivers that you want to add. Or you can actually go and find specific examples. You can load that example, run it, use it as a reference for how you would want to do your project.
Yeah. And I believe, again, I believe, again, Glenn Nilsson has done a couple videos specifically using the 817 to run a couple of examples. Yeah, so good question. Thank you.
Thank you.
Just to go back to the computer screen, into the create new project. So we've parsed through the available parts. We happen to know, since we have the 817 Explain Pro board, that we're using obviously the attiny 817. So I'm going to type that into the filter on device field, and here it's I'm just typing in the number, and you can see it actually parses through all the products and pulls up the available parts that match that number. You can see there's a few boards available, the Mini that we showed, the Pro board, and there's also a Q-Touch Moisture demo board that actually you can pick as well. But what we're going to do here is we're going to select on the attiny 817 Explain Pro
and
board.
just a quick comment here, because you may see that some devices are listed in numerous lines, but that would be potentially because they're from different packages.
You're right.
So different packages
Right.
can actually have a different pinout or different number of pins, so that would give you some variance there.
Absolutely.
So if you're in doubt, just look at the device you have and choose the right package. But otherwise, as Mark is saying, if you choose a board, if you have a standard board, you have that listed, and that would help you a lot.
And what happens is, yeah, if I select that board, what's going to happen, and you'll see in the subsequent pages here that it actually configures the project specifically for that board. I mean, we have LEDs on there and push buttons and actually capacitive touch sensors on there. Configures the project to accommodate those accessories. So what I'm going to do inside of the Start Create a Project window is just create a project now that I've selected what I want. And you can see that it's going to take a second to actually load all of the functionalities and actually create that project for you. And there we go. Okay, so what'll happen is once everything's loaded, it brings you to this dashboard page. And the dashboard page is kind of your home page that gives you an overview of your entire project. And Jacob, I noticed down here there's actually been added a couple of blocks that we didn't intentionally add whenever we were setting up the project. Can you explain those?
That's a really good point. So we have on a regular basis received a few questions. Say, well, what if I want to configure the sleep manager? If I want to configure the brownout detection or clock system, and these 4 blocks that you see down here, they are added to all projects by default, because that's something that we know that you will use, you will need it at some point. So if you want to add something of the very basic functionality, maybe it's already included, so you don't need to add it manually. But go in there, if you click one of those boxes, you can see how you can configure the sleep controller, the brownout detection, and whatever else in these basic and very fundamental modules.
Absolutely, and I just clicked the sleep control and you can see there's a couple of different drivers, there's some enables and so on.
Yeah.
And you know, as we mentioned, there's that contextual help as well. And I mean, if, for example, I click on one of this core functionality, and I'm not quite sure what some of these things mean. First of all, there's a general, under the general, you'll see there's a user's guide for the specific component. And if I click that, what it'll do is kind of give me a bit of an overview of it, a little higher level than what you'd find in a data sheet. But if you did want to see a little bit more detail on specifics, so for example, under the sleep enable, if I click the little question mark here, it opens up an HTML version of the data sheet where I can actually take a look at what that specific thing will be, or that specific capability will be.
And this is quite novel, I would claim. Because usually, I mean, we all know the downloaded version of the PDF. Well, if we go further back, we actually had a book.
Actually, paper, yeah.
But
Remember
PDF
paper?
is searchable, but this is context aware. So here you don't even have to find the right register. You need to find the right functionality that you can do here in Start, and that would take you directly to the registers. And that's a big difference.
And again, saving you time on that rapid development, right? Matt, there's a question?
This is a great time to ask this, so I just wanted to jump in before you moved on. Some of the users were asking about the clock source section specifically. So could you kind of give us maybe a couple-minute overview of how to set that up and what the different options there are?
Of course. So
I think we should just wrap up on the documentation.
Sure.
Because there's a quite good documentation here as well. If you go to the bottom of this page, that is quite helpful for you. So down there you have all the details about that specific device. You also have the opportunity to actually order the device. You have the purchase option, and you have the data sheet and so on. So we've put it all at your fingertips so you can easily start using these products and find the right information and access the right pages that you need.
And actually, if you decide you want to change the package, you can do that here. If you want to do things like change up and add some additional components, you can do that here. Now, the question concerning the clocks, if you take a look over here on the left-hand side, you'll see that there's a couple other tabs. One of those is the clocks tab. And you know, one of the things as microcontrollers get a little more fancy with their clocking systems, because there's always a motivation to move into lower power, faster processing capabilities, all that sort of thing, more dynamic clocks that you can change on the fly. So clock systems can get a little complicated, and if you go into a data sheet, it can get a little bit confusing. Whereas here what we've done is inside of START is kind of backed off a bit and showed it kind of more as a series of blocks, and you can see where the connections are. You can see over here on the left your oscillators. Over here in the middle is your clock sources. If you want to configure those, you can come in here and just click on that gear and it'll open it up, and you can see you have a number of different options available. A low power 32.768 external crystal oscillator if you're going to use that, 20 megahertz internal oscillator. You can also see that there's different options for that. So if you want to pre-scale that, if you want to, you can enable that. Again, what does this mean, pre-scale division? I can click on that question mark, and again, contextual help. It opens up to that page to what you want to know, so you don't have to go paging through anything.
So and for this specific device, so the Tinys, they're using the internal RC oscillator. So if we just have a look at the screen again, you'd see that the internal oscillator is set up for, I think it's 20 megahertz as default, and that because depending on the supply voltage for the device may not be able to run at that speed if you have, let's say, 2.5 volt. So what you do is that you start at a lower frequency, but then you can actually bump it up to something higher. So the default frequency that this is running on is 3.3, but you can actually increase it. But we'll keep it there for now because we need that for the example later on.
You know, another nice thing too is you can actually see on the right all of the peripherals and other components that are actually making use of that clock. So, I mean, it's not as an abstract thing whenever you're looking at registers in C code. You can see it here as a block diagram, which I think is very intuitive.
And you have that, well, I was about to say the same block diagram in the datasheet.
Right.
You don't have the same representation. You have that in the datasheet format, if we should call that. But you would see the same things there. So you would see that the CPU, the RAM, and so on is connected to the main clock, and how that main clock is then generated, you can configure from here.
Very cool. So let's go back to the dashboard for a second. What I want to do is just kind of click onto the noise. Well, first of all, let me show you this. So we talked a little bit about at the very beginning when we were adding drivers. So, and by drivers I mean we're adding peripherals, right? So if I click on Add Software Components at the top here, you can see I can add some middleware if I wanted to do things like a bootloader. And so on. You can also see our noise click is actually in there. If I click on drivers, this is how I would actually add components if I wanted to use some other peripherals on the device. So the PWM, if I wanted to use the SPI, customer was talking about the RTC, you know, and so on. I could just add those components and add it there. So you're not stuck with what you originally configured.
And the point here is that this is searchable.
Yes.
So in the top of that dialog box, you have actually a search field.
Yeah.
So if you want to add, let's say, an SPI interface.
That's funny, you should say that.
Oh, that was what you were typing. Thank you. So then you would not only see the SPI module for the AVR, but you would also see the UART, because that can do SPI master mode. Or rather, it would take you to that later on, because it would just allow you to select the SPI, and that would then be able to run from different modules. So there's a lot of abstraction here, but it's something that will be very clear to you as you move forward in the different steps.
And something I never even noticed before, but take a look at this. It actually adds a bunch of clicks that actually interface over SPI as well. So if you wanted to add those clicks, you could. So that's kind of cool. Okay, so if we come back into the project, you'll see here that we actually have a component box for our noise click. So what I'm going to do is I'm going to click on that. And what you can see is that it has a kind of a easy setup window that kind of opens up that allows you to kind of quickly configure this this click for yourself. If you go over here to the user's guides or the general section, there's a couple of things here. So the user's guide, you can go to the product page at MikroElektronika and find out more about that click. It gives you kind of an overview of what this click does. And this guide just kind of gives you a signal whenever you've gone above a certain threshold, and then you're going to see how it reads an A to D reading, and then we're going to print that off to a serial port. If you want to rename the component, you can do that. If you want to completely remove it, again, you're not stuck from what you originally configured it, you can do that as well. So the dependencies here are going to be, you also see them listed up here. We're going to be using the A to D, we're going to be using the SPI in master mode. And you'll also see that we have add a USART async here. And what that means is the example we're going to use actually is going to print information to a serial port. And in order to do that, we're going to send that over a UART. And Jacob, that's a feature on the eDBG, the MEDBG, the serial monitor, correct?
Yes. So what you have there, so I already mentioned the power monitoring, but as you say, we also have actually a serial bridge that can take it from any serial interface, and you would then be able to stream that to the PC. So it's a bridge between, in this case, UART and USB, and you would then connect to a terminal.
Yes.
So, but that is something that we also have integrated in Studio to make it even easier for you.
Yeah, and not something you find on many computers anymore, but what, you know, if you're an engineer, was a super handy.
Cannot live without it.
Yeah, it was a handy interface, you know, so we've brought it back to you. So going back into the easy setup here, we're going to use the SPI master mode, but what I'm going to do is I'm going to add this USART here, and I do that just by clicking on it. And you see now that it's
so
added.
in there, just to add that comment, so you may notice that it was a sort of dotted line around that.
Yeah.
And that is because the example that this driver is offering you can actually do something with the UART. So it's giving you a hint
Yes.
that this is something that you probably want to include, and then we'll see why.
Yeah, again, so that you don't go generate everything, go into the code, and then, oh, why is this not working? Oh, well, I didn't enable this, correct? So what we're going to do too is we're also going to come in here and we're going to see that, okay, we're using an A to D, but there's also an int pin. And what I did was I went to the microbus expansion module that we currently have connected to the Explain Pro board. Again, that's going to accommodate the click. But there's a pinout header on there, and there's a pinout table inside of that user's guide that actually allows us to map to this particular click.
That sounds a little bit complicated.
It's actually quite easy.
Oh, I'm glad you say that. We're probably going to see that.
Absolutely. So, in fact, if I don't know if you can see this, and my apologies if you can't. This was kind of this is an unplanned thing.
We can't really see that.
So you can't really see it apparently. But anyway, what I did was I just went into the Explain Pro standard extension header, which is table 3-1 if you want to get specific, for the Explain Pro microbus Explain Pro connection daughter card here. And all I did was I just went in and I mapped out the pins, which are actually defined on the Explained Pro board here. I just mapped them to the header, and it was actually quite easy to do.
So you have two headers in this board. You have the expansion header 1, so that's written with very tiny silk screen here, and then you have expansion header 3. So header 2 somehow lost its way onto this board, but we have these two headers, and you also have the marking in silk screen, all the pins that are brought out, so the name from the device side to this header, and we'll look more into that.
Of course. We have a comment from the booth.
Hey, Mark, you want to just give us that number one more time, and I can throw it up on the live chat just in case people are following along for the datasheet section?
The number for the table?
Yeah.
Okay, it's table 3-1. And if you're looking for that document, you know, we'll show you how to find that when we open up Studio, okay?
All right, cool.
Table 3-1. Okay. So anyway, so that's how we map the pins. Going back to the start here, you'll see here one of the signals is int. And what happens is on the output of this clipboard, there's actually a comparator. And what it's going to do is when you surpass this threshold that we're going to define later, it's going to trigger a high on that pin. And that pin happens to be connected to, thanks to my mapping that I did with that table on our PA5 pin. I'm going to come down here into hardware configurations. Now the pin select for the ADC, thanks to my mapping, I know that that's ADC 6 or channel 6. And finally, what I'm going to do is I'm going to set up this threshold value. And just from doing some bench testing on my own, I came up with a value of 50. We'll show you later how to actually do a little bit of bench testing yourself if you want to change that.
So if we just repeat what the module actually does, it is measuring the signal from a microphone.
Yes.
It is then comparing that signal to your reference level. So we just keep it simple here. And that is what you just set up, the reference level. So if it's passing that level, it would generate an interrupt. But you'd also be able to read the microphone power level with the ADC, and that's why you have the ADC there as well.
Right, and I mean, there's a lot going on in this little circuit, but again, it's been put together for you so you don't have to do the bench testing with it, and again, the schematics are available. It's kind of an open source thing. Now, we're going to be communicating with a DAC on this board, a Microchip DAC, by the way, and in order to do that, we're going to use the SPI. So I'm going to click on that, and there's a couple options here based on the product that we're using to use SPI. What I'm going to do is I'm going to, because I know which header I'm on, because I did some pin mapping, I know that my master in slave out is going to be on PC1. And because I configured that, it automatically configures the other pins, which is going to coordinate between the MCU, the header, and then the micro bus. Okay? I think that's about it. One last thing inside of the noise click main window, you'll notice that there's a generate example. If you don't want to generate that example, you can unclick that, but for our purposes, what this does is it gives us a nice out-of-the-box kind of demo of the clipboard as it's being used in START.
So it's sort of a combination between adding a driver and an example at the same time, so you can actually see how it's used.
Exactly.
That's cool.
Yeah. Now, we did some pin mapping. If you're curious and you want to see where those pins reside, there's a third tab here that we didn't look at called the PinMux. And the PinMux is a cool visual way to take a look at our MCU and the various signals.
So on there you have the package, for instance. So if you change your package, you'd also change this image.
Right, right. And if you zoom in, zoom out, you can see there's a number of different fields there. You can change those fields by selecting or deselecting. You'll see that there's the component name, the signal label, how we label that on the board, and so on. Okay?
And you can say the reason why there's so many different options is that depending on whether you're the hardware engineer, the software engineer, firmware engineer for that matter, you will maybe have different preferences. Are we talking about net list? Are we talking about a definition of a label that you use in your code? So all of that can actually be fitted into this table and will be very helpful for you later.
Right, and one of the things too is that I didn't mention when we added the UART, because we selected the attiny 817 Explain Pro board at the beginning, our UART automatically got mapped to certain pins. Now these pins, as Jacob mentioned, are going to communicate with the EDBG circuitry, and that's going to convert our UART signal into a USB signal that we're going to visualize later inside a studio. But if you take a look at the PinMux, you can see here, if you ever need to reference this, if you go into the header section on the table to the left of the package, you'll see that it's actually labeled here as virtual COM port, clock, virtual COM port, or it tells you the UART receive, UART transmit as the pin label, and so on. So very intuitive. Down here you can also see Q-touch buttons and the LEDs and so on.
So when we're talking about the virtual COM port, that is actually the COM port connected through the embedded debugger to your PC. And then, as you say, because it's a UART, you have those specific signals.
Right.
Yeah.
So again, trying to keep everything as intuitive possible. Now, if for whatever reason you get confused as to what different things mean on this page, again, contextual help. Here's a circle with a question mark. Click on that, and what it'll do is it'll pull up a whole explanation of what this page does. It gives you a tip at the bottom, and then you can see there's also, if you want to explore some other things over here on the left, the Atmel START User's Guide is a great place to go here.
Cool.
Okay. What I'll do is I'll go back to the dashboard, make sure everything's good. I
can just inject one more comment
Sure,
there.
please.
So we have 3 tabs out on the left-hand side. You have the dashboard, which is for your software modules. Then you have your pin mux, which is what you just showed, how you can configure your pins. You can configure it for input, output, set the pull-ups and so on. You can set your labels. And then you have the clocks. If you add other stuff like the event system, which this device actually has, that would pop up another tab. You would have the one for the custom logic. So all of that which is special for this device would pop up, and it would help you configure those specific modules.
Yeah, and the event system is an excellent example. It's a great peripheral that ties all these different signals within the microcontroller together to make other things happen. So say your comparator goes high and you want to trigger a timer or something. If you're looking at registers, that can get confusing, but doing this inside of START, you see the block diagrams and you can connect the signals. Good point. Okay, so there's other things you can do here. As Jacob mentioned, you can order parts and all that. Up here, there's a view code if you want to see the code that's going to get generated before you actually generate the code. But we're, in the interest of time, we're just going to go here and export the project. And what this does is it's going to package your Atmel START projects to be used in an IDE. Now, Jacob, I noticed there's Atmel Studio here. There's you want to make a Makefile standalone, but there's also IAR Embedded Workbench. Why would we use IAR Embedded Workbench over Studio?
So Studio is the product that we provide to our customers for free. It's a very good IDE, very good editor. You have debugging, you have the GNU GCC compiler for AVR included in Studio. But if you want to go a step beyond that, if you have a commercial product where you need to squeeze that code down from 9K to 8K to save a little bit of money, then you would probably go to a commercial compiler like IR. So IR is the best in the market for the AVR and can really shrink your code to an absolute minimum. Another good thing about IR that I just have to mention now that we have the opportunity is that debugging capabilities are really, really good. So while in some compilers, if you increase your optimization, that decreases your abilities to do debugging.
Right.
But in IR, you can actually turn up the optimization quite high before debugging is starting to become an issue.
Very cool.
So, and IR is having Kickstart version. So if you want to experiment with that, you can either have the 4K limited version, or you can have the time limited version instead. So that's a good thing. But we're going to use Studio today. That shows you some of the integration we also have between START and Studio, which is really, really neat.
Very cool. Okay, what I'm going to do here now is I'm going to just, I'm going to name my project, so I'm just going to name it Noise Click.
Noisy Mark.
Noisy Mark. And I'm going to download the pack, and what this is going to do is generate a file called a .atzip file. And that's going to be, depending on the browser, I'm using Chrome here, but what I'll do is I'll show you how to get that from within the START, or the Studio IDE, which I actually have open in the background. You can see here that I've got the attiny 817 Explain Pro board plugged in, and what happened is this page popped up, and it shows all of the different documentation, like the data sheet, technical documentation if you want to get the user's guide, if you want to get the schematics for the board, that automatically populates, including things like the part number and so on.
And even the extension board would be possible to find. I think you have that on
right here
on
under
your
extension
side.
board. If I click that, again, that pops up. Now, we were referencing a table in the document to do the pin mapping. We were asking where to find that. Just go right here. Okay. So what we're going to do is I'm going to go back to the studio here, and I'm going to import my project that I created in Start. So I'm going to go into Import. I'm going to go Atmel START Project, and this opens the Import Atmel START Project dialog. I'm going to go to Browse. Now, I've done this before, so it automatically defaults to my Downloads folder. I'm going to click on the noise click here that I've generated. Now you'll see that it populates a project name. You can change that if you want to. It also gives you the location where your project's going to be stored. You can change that again by just clicking Browse if you'd like. I'm going to do that. I'll just go into, where is it? My Documents folder here. I've got Atmel Studio. I've got boo-boo-doo, and then Sandbox, and then I'll just add it right there. I'll select that folder. Okay? Click OK, and now you see what happens is all of the C code, all of the folder structures, they're getting generated in the background. Okay? Now.
So now you've actually imported the file.
We've
now
imported the file.
Now you have taken that zip file, the HZip, expanded that,
exactly,
thrown that into your project, and you're ready to go.
Absolutely. Now if we take a look over here on the right, and this is going to depend how you've got your studio set up, because again, we make it easy. You can move this anywhere you want. But you'll see here that under the folder structures, we have a couple of things. The one that I'm going to be concerned with is examples. And if I open that up, you'll see that there's a number of examples for the peripherals we've added because we're using this click. So the ADC example, an SPI example, and Jacob, those are there if you want to reference, correct? If you want to.
Correct.
Yeah. So if you want to get up and running using these peripherals quickly, we've actually generated some examples for you. But here's the click example here. I'm going to go ahead and click on that, pardon the pun. And you'll see here that inside of that noise, or inside of that click example, you'll see that there's a noise example, which actually just printfs a bunch of information out for you. Okay? So we're going to make use of that. So let's go back to our main file. And here's a really nice feature with Studio. So I happen to know that I have a function called noise. So if I start typing that, check out what happens. It automatically opens up this, this little dialog, and I can autocomplete and enter my example of functions that are recognized by the IDE. So again,
so, and that is of course not only the files that you have added, it's all the standard files, the standard libraries, all of that would come up. And also one of the things that is very special for the pin mark stuff that we did, if you add a label there for a pin, that label is actually transferred into the project here. So if you have, let's say, a status LED label, you can use that status LED label underscore toggle dot toggle to use that specifically, or UART, you can name that specifically. So that's pretty cool that you can do that.
And make this like a really readable code. Now what I need to do here, let me zoom in a bit on this so you can see a bit better. But what I'm going to do is I'm going to add the include file for the click example, and all I need to do is start typing. I can hit enter, and there it is. The next thing I'm going to do, just to make this example a little more readable to you, our viewers, is I'm going to add a function called delay milliseconds, and I'm going to put that at a second and make sure I add the
And what you may notice when Mark did this was that not only does it help you do the autocomplete, but it also shows you parameters, and different descriptions, and so on. So it's very, very convenient.
The other thing we're going to need to add here is because we're using the delays, we're going to have to include a included library file called util, and that's going to contain a header file called delay.h, and that's going to make sure that we can use this delay function.
And that was the dependency you just mentioned.
That's right.
So if you're in doubt what include files you need to include, that would be part of the information for that function.
Again, so minimize your getting something up and running that's not quite working, you don't know why. We're going to try and give you as many hints as we can. Okay, so what we're going to do now is we're going to select our board. And to do that, I'm going to click on this button here, which is going to open up our project options. And you'll see here's our tool, and we're going to want to select our attiny 817 Explain Pro board.
And those would always come up as a EDBG, embedded debugger. And if you're so lucky that you have more than one or more than one tool, you actually have a serial number on the back of that tool, and that serial number is also reflected in the dialog box. So you know exactly which board you're actually debugging.
Yeah, so that's what this number right here represents, and then you know at least you're programming the right board. Okay, so what I'm going to do is I am going to keep this in debug mode, and I'm just going to click on this Start Without Debugging button at the top, which is the green triangle. And what's going to happen is I'm going to go through and I'm going to compile my code, and then once that's finished, you'll see down here at the bottom I'm actually writing that to the chip. In Jacob, the memory usage here.
Yeah, of course that's very relevant if you're using an 8K device and you're closing in on the boundary. So it shows the memory consumption, both of the flash and the SRAM for data in that dialog box.
And it also shows 25% of our 25.7% of our flash is being used. Now,
Sounds like a lot.
it does,
For such an application.
but when you consider we've added that printf statement that's being used in the example, printf comes with a lot of baggage. There's a lot of overhead on that. Now, we're using it here today because we're communicating over the serial port. However, in a usual application, you may just be using this to trigger an LED or some other way of letting the user know that there's too much noise somewhere.
Send raw data through the UART.
There you go. There you
There
go.
you have it. Then you're getting rid of the printf.
And it gets rid of all that overhead from the STDIO library. Okay. So now that we're connected, or that I've downloaded to the chip, what I'm going to do now, I could use a third-party piece of software, terminal emulator, to check out what's going on, but
why would you?
why would I? When I've got Data Visualizer integrated into this beautiful IDE. So if I click Data Visualizer, what's going to happen is it's going to pull up a couple options. You can see there's many more options if you go under configuration here, but I'm going to use the serial port option here. Oop, hang on.
So actually, I can just throw in a comment here while you're adjusting this. So the visualizer can do what Mark is going to show text, but it can actually do the graphical representation of data coming across.
So if you were doing like an analog input, which this actually does, you could actually map that.
You could.
That's very cool.
So you can see that how is the sound level decreasing, increasing, varying over time. But we're not going to do that.
No, we're not going to do that today, but I mean, I encourage you to explore some of these capabilities. I mean, the Pro board with all of these tools, just a wonderful evaluation platform. Okay, so just to drive this home here, if we go back into Data Visualizer, you'll see I can select my COM port. If you've ever used other third-party tools, usually they just list the COM port, which can be a little bit of trial and error to figure out which one you're on. Right here, we've actually called it the EDBG virtual COM port, so that makes it easy. And then I just click Connect, and then there is our output. So you can see if I tap this, as the noise threshold goes above 50, which we've got identified there, it's going to tell you that there's a lot of noise. If we stay below that 50 threshold, then it looks like we have perfect ambience, which I thought the minute I walked in here. Cool. Now, if you want to go ahead and make some changes to this project and maybe change that threshold, for example, over here in the Solution Explorer, you'll see that there's a button that you can click, and that'll reload Start for you. You can go back in and make some changes. You'll see I've got that window docked here. You don't need to have it docked. If you need more room, you can pull that out and you can expand it like so.
So that's a really, really important feature, because as most embedded designers, I'm sure that you don't add all the drivers you need right away.
Right.
Maybe you start with your Hello World and your UART, and then you realize a bit later that you need the ADC as well.
That's right.
So reconfiguration with Start and Studio is integrated.
Excellent.
Cool.
Wonderful. So that kind of wraps up the demo. Guys in the booth, do we have anything to add here?
Hey, Mark. Yes. So we've had a bunch of great questions come in, and
Lots of it.
rather than several of the questions have kind of pertained around the similar idea. So if you could take us through a little bit about the click libraries. Are they open source? Are they locked? Is that something that people can come into and change and update on their own? The source files for those click libraries, as well as with the clicks and with the boards that you use today, where can people get more documentation as far as the schematics and that kind of stuff is concerned?
Really good questions.
Yeah. So did you want to take this, or should I? Or
Yeah, sure.
Okay.
So the source code that we provide for the clickboards is something that is open to all of you, like every other code that we make. Use it for whatever application you want to do. Of course, you want to use a Microchip controller. That's a given. But you can use the code as you see fit to develop your applications. And all of the source code is open. There's no closed libraries for any of this.
Yeah, I mean, you can, and this is, there's a lot of new peripherals coming out all the time, which, on the surface may seem a little daunting if you're not familiar with them. I mean, the event system, you may go in and you may find this, there's a lot of content on there. But you step back, you take a look at it from the start perspective, you can see the block diagram of what this thing can do. Then you can generate the code. And now you can use that block diagram, which also corresponds with the data sheet. And you can go in and use that as a reference, because all the code is there, how to configure the registers the way you need it to be specifically for your application. So it really minimizes the learning curve for things like that.
And I think I just have to inject one more comment here, because since there was a question about documentation, so all of this is documented in START, and you'll be able to find it. But one of the very neat features when you generate code from START, it would actually give you files, configuration files as well, and you can generate the specific documentation for your project with all the APIs that you're using, and have that as a reference on the side. What was those APIs again? You have it there, it's browsable, it's HTML, so it's very, very convenient. Unfortunately, we don't have time to go through that in details now.
Yeah.
Thanks, Jacob. We could see you're a big fan of Atmel START.
Yeah. Well, it's hey,
Right,
and I'm a good example here too. I mean, for me to be able to give you guys a demo on this, I'm a fairly recent user to this environment. Here I am
You look
giving it-
completely green, honestly.
Exactly.
No,
So,
no, you
I
don't.
mean, it's
you
it's
look like
gr-
a seasoned veteran.
awesome. Well, it's truly an intuitive environment, and I'm a
seasoned.
huge fan.
Almost overdone.
There you go.
Hey,
Any other questions?
Yeah, one more we'll cover, but before we do that, as we promised, we have 3 click prize winners, and each of you out there that are one of our winners are going to get a noise click board, so you can follow along. Basically, just redo what Mark did and made it so simple and easy for us. So those 3 winners are, and to get your information, just go ahead and email livestream@microchip.com.
And we're going to put that at the bottom of the screen as well,
Yeah, we'll throw
just
that
in
up
case
there
you
for
can't understand what he's saying.
And that's a great way to build the suspense too, because you said, and the winners are, and then you moved on to something else.
Yeah.
Mastercraft, right?
And now we get to listen to Matt actually try to pronounce people's names.
Yes,
this is
this
the
will be
fun
fun.
part of every live stream.
So I picked an easy one. Fabian, thank you for your great question. We're gonna send you a noise click, as well as Adam, and the last one. And I apologize if I mess this up, but I believe it's Mudasir. You also, thank you so much for your participation. You've asked a lot of great questions today.
Actually, you've asked all the questions. You
have-
win the award.
You win the award, absolutely, which is a noise click. So congratulations on that. So we had one last really good question that I wanted to make sure we got asked. Is the ATM bus adapter X Pro usable with the Explain Mini boards, such as the Atmega 328P Explain Mini that this user received at a Microchip event?
So for the mini board, you don't have any headers populated, but you have the, as I mentioned initially, you have the Arduino headers here, and you also have a header here where you can actually populate the equivalent of the X Pro header. So yes, you can actually do that, but you have to mount the headers yourself.
Cool.
Very succinct.
Thank you, Jacob. That was great. Everyone out there, thank you so much for
Wait-
participating
Wait a
today.
minute now. You didn't get my favorite question. You
Oh,
didn't ask my
I
favorite question.
apologize. That's true. We did get one last question
I actually want to see Jacob answer
of
this question. That's fine.
utmost
Oh, that's for
technical,
Mark.
utmost technical importance. And that is there a dark theme to Atmel Studio, or are we forced to go with the gray option?
So you're forcing me to show my laptop now.
Uh-oh.
Yes, there's a dark theme.
All right.
Look
let's-
So
at
let's
if
that.
take a
you're
look.
one of those guys that cannot stand the white background, you can use the dark theme. And there's a lot of plugins for Atmel Studio that will do crazy things that you dream about that will help you a lot when you're writing code. So Atmel Studio is a really nice tool. Go into the gallery, find all the extensions, enable the dark mode. Really nice stuff.
I knew that.
I appreciate the question. That was a good one.
Absolutely. I dream about Atmel Studio a lot, so thank you for answering my question on that as well.
You need a hobby.
Cool. Probably. I'll take up sailing. So just a heads up for the future. Once again, I wanted to plug our next live stream. It's going to be out Monday night. That'll be 9 p.m. Mountain Standard Time. So come out, check us out. If you're in the U.S., if you're in India,
The
hopefully
Far East.
the Far East, yeah. I think-
It'll actually be what, in the morning?
yeah, in the
time
morning,
there?
I think.
9 in the morning.
Grab some breakfast, grab some cereal, sit down, and join us with Mamoon as he talks about prototyping with on a PIC device in that one. So similar to today, but different IDE. It'll be real interesting, and I'm excited personally for it. And then if you guys want to continue following just the live streams as they come out, maybe you missed something today and you want an easy way to find out that, or you just want to grab the parts that Mark and Jacob talked about today. We have a new webpage up. It's microchip.com/live streams.
And hopefully it's live stream. Hopefully,
Live stream,
hopefully
live stream.
our tech guy over there in the corner will be putting this down at the bottom of the screen. Otherwise, we'll throw it in the description.
Yeah, I'll throw that up in the description for you guys. But that's going to be where we store all the information on our live streams moving forward. So what's coming up next, what parts they are, really easy way to go buy them yourself. So that'll have a lot of great information as time goes on. Mark, why don't you sign us out?
Sure. Hey, Jacob, thanks again for joining us. Have a
It was
safe,
a pleasure.
have a safe trip back to Norway.
Yeah.
Everyone who joined us and asked questions, thank you so much, and we'll see you next time. Thank you.